Now in section 14.6, we introduce the ROS joint trajectory controller. So far, our action servers for interpolation have been simplistic. The joint trajectory controller package, which is part of the ROS controller stack, will offer a much more advanced set of features. Number one, it is able to do it's able to generate different kinds of splines, including linear, cubic, and quintic. Linear splines only specify position and guarantee continuity at the position level, but not at the velocity level. Cubic splines require position and velocity and guarantee continuity at the velocity level. Finally, quintic splines require position, velocity, and acceleration to be specified and can guarantee continuity at the acceleration level. Again, this kind of continuity is important for the smoothness of functions, to lower the effort generated by torques, achieve more efficient trajectories, and there's a host of properties that just benefit robots when we have this kind of motion. Other things that we can do is preemption, or preempting trajectories. That means that we can cancel existing action trajectories by a command or by sending new action goals. Both of these work. When we send a new action goal, what we're actually going to do is a trajectory replacement. When we send the trajectory replacement, we can choose a time in the future, whether it's immediately or later in time. One cool feature about trajectory replacement is that the code tries to do smart integration. That is, it tries to ensure the smoothness of the function so that the transition is not jerky. Click on the link for more information about how that happens. This advanced action server is incorporated in Rethink Robotics Baxter interface package. The package can run, or the action server can run in 3 different modes. Velocity mode, where you get a fast motion but not accurate positioning. The position mode, where you get better position movements but at a slower speed. And finally, mode position with inverse dynamics. This uses this is the inverse dynamics feed-forward mode that provides you with the best speed and the most accuracy. To run the trajectory server, you need to say ROS run, Baxter interface, joint trajectory action server.py, mode, whichever one you want to use. For the inverse dynamics feed-forward position mode, it'll take position, velocity, and or acceleration. Position is required, but the rest of the information is optional. However, if only position is provided, this will work similar to position mode. MoveIt is a package that will publish both or all position, velocity, and acceleration data for the robot. And so this will ensure that a trajectory action server like this works in the most accurate way. For the trajectory splining, or the way the interpolation happens, is that we're using splines through the Bezier library. So click on the links for more details on those. And something to note about cubic and quintic splines is that they're only possible when we provide both start and finish points. Some information about topics, just for reference. The client goal and cancellation topics for Baxter can be found at robot limb, right or left, follow joint trajectory, and then goal or cancel. The type of those messages is also included. And if we want to know status, such as results, feedback, or status, we have these topics as well. We can test 2 clients from a new package called the Baxter Joint Trajectory Controller Client. The first of these two clients is called the pre-pose client, and this is going to move the right arm to the home position. The second one is the what they call the home client, and this will move the right arm actually not to a home position but more like to a straight arm position. This second client will also allow the user to select a time to completion, for example 1 second, 3 seconds, 5 seconds. And doing so, we will be able to explore when velocity constraints by our planner are violated by motion. That is, if we ask the arm to move too quickly, we might violate velocity constraints set in the planner that would not generate a smooth motion. So let's try to see how that works. First, let's make sure we're running this joint trajectory action server. From before, I will kill these windows. So this is from the Baxter interface, sorry. Joint trajectory action server. And then Baxter joint trajectory control client. Pre-pose. This is just keeping the arms where you see them right now. And then we can use home. So now this is going to ask me for a duration, and I can maybe select 5 seconds. And you can see that smooth motion. Then I can go back to pre-pose again. You noticed again a quite smooth motion. Let's try home one more time, but make that motion a little bit faster. So 3 seconds. And so far, finally here we see that the code has aborted. Let's send it back to pre-pose and check with 5 seconds one more time. We got an aborted there at the end. Five seconds. So here we got a succeeded report. And this has to do with how the motion can guarantee the smoothness according to the splines. If we do home, let's say with 1 second, that'll be a very fast motion, and we get an aborted event again.